Imaginary numbers appear at least once or twice on every ACT. Sometimes, when imaginary numbers are used, they give you the definition of I, which is equal to the square root of -1. Other times, however, they don't give you anything and you're expected to know that I is equal to the square root of -1. In this video, we're going to review imaginary numbers and do a couple of sample problems. The imaginary number I, when taken to different integer powers, follows a specific pattern. We already know that I is equal to the square root of -1. If we take I squared, that gives us the square root of -1 times the square root of -1, which is simply equal to -1. If we raise I to the third power, that's equivalent to taking I squared times I. So since I squared is equal to -1, we get -1 times I, or -I. When we take I to the fourth power, that's like taking I squared squared. So since I squared equals -1, if we square -1, we get 1. Then we start over, so I to the fifth would then be I to the fourth, which is 1, times I, which is just the square root of -1, and so on and so forth. So that pattern repeats itself every 4 powers. Let's do a couple of sample problems using the identity of I. Simplify 3 plus 2i plus I squared minus I cubed. So we have 3 plus 2i. I squared is -1, so -1 minus I cubed, which is -I, so that's going to be plus I. So now we can combine the like terms. So we have 3 minus 1 is 2, and 2i plus I is 3i, so we get 2 plus 3i. Now let's simplify x plus 3 times x plus 2 all over x minus 3i squared. So that will give us on the top, we're going to keep the x plus 3 times the x plus 2. And on the bottom, we're going to get x minus 3i squared. I squared equals -1, so -1 times -3 is positive 3. So that'll give us an x plus 3 on the bottom. We can actually now cancel the x plus 3 in the numerator and the x plus 3 in the denominator, and that will just leave us with x plus 2 as long as x does not equal -3. Evaluate I to the 75th power. We know that when we have I raised to different powers, we have a pattern that repeats itself every 4 powers. So we can actually break down I to the 75th power into I to the 72nd power, because 72 is divisible by 4, times I cubed. And that's going to be equivalent to I to the 75th power. So I to the 72nd power is just I to the 4th to the 18th power. And of course, that's just going to equal 1. So then we're left with 1 times I cubed is equal to, we know that I cubed is equal to -I, and -I times 1 is just -I. So that means that I to the 75th power is simply equal to -I. Which expression is equivalent to 5 over 3 plus I? For whatever reason, mathematicians don't like when we have imaginary numbers in denominators. So what we want to do is get I out of the denominator. So here's how we're going to do that. We're going to take 5 over 3 plus I, and we're going to multiply that by 3 minus I over 3 minus I, because we know that's equivalent to 1. So that'll leave us with 5 times 3 minus I in the numerator, and the denominator, that's going to leave us with 9 minus I squared. We can simplify the denominator even further, so we'll leave 5 times 3 minus I in the numerator, and then in the denominator we have 9 minus I squared. I squared is equal to -1. So that's the same as 9 plus 1, or 10. And we can see now that 5 times 3 minus I over 10 is the same as 3 minus I over 2, because 5/10 can reduce to 1/2. So that leaves us with answer choice A, 3 minus I over 2.